Hello there, this is lesson 4, year 13 maths. Another look at vectors, exercise 19e. And solving geometric problems, it might remind you a bit of the kind of work you did at GCSE rather than A-level, presumably at a slightly harder level. But nevertheless, there is a definite overlap between these two types of questions at GCSE and A-level. So reminder of a few rules that we've seen in year 12. If you get two vectors, A and B, and you want to know where it's halfway between them, it's like the formula for the midpoint of two coordinates. It's a half of a plus b. If two vectors are parallel, so we've got a vector here a and a vector here b, if they're parallel, then we can basically describe one in terms of the other. One is a multiple of the other. So here I'm saying that the vector b is t times the vector a. Very often, to be honest, it's written like v equals k times by some other vector u. I'm putting lines underneath the vectors, but you don't need them. But you need to know that they are vectors. And so if I have, for instance, a vector, let's do this one here. If I say that a equals 2, 1, and b equals 6, 3, you can clearly see one has been trebled, the other one's been trebled. So you could write therefore that b equals 3a. And that's all I'm saying, really. And on that basis, B and A are parallel to each other. They're going the same way, just one's a longer version of the other. And a unit vector, well, these are important too. They're usually written with this little hat on top of them, a hat then. To find a unit vector in the same direction as A, you basically find the magnitude of that vector. You divide by it. So if it's got a length of, for instance, take this one here, B, magnitude is the square root of 6 squared plus 3 squared. What's that? That's 36 plus 9, that's 45, so it's the square root of 45. And you'll probably suss that you could write that as 3 root 5 if you so wish. Now, when you do this then, the magnitude of 3 root 5, if I want to write b as b hat, all I do then is I do 1 divided by, I'm going to write root 45, I think I prefer it. You can type into your calculator to get a better answer, times by the original vector. What was it? It was 6, 3. 0, 2, 1 for the A. And that's it. That's all you do. You just divide by the length of the original vector. So let's go through this. Find the midpoint of the vector AB. Well, that's easy enough. It's probably best writing it as M. And therefore the position vector would be OM. But I'm just going to add them together. 2 and 3 makes 5. Oh, half it. Don't forget to half it. So it's 5 over 2. Could write 2.5, I suppose. 5 take away 2 is 3, so that's 3 over 2. Minus 1 and 5 is 4, so that's 2. And there we go. That's my vector. That's all you do. Add them together and half it. Notice it said, oh, it didn't say actually what's the coordinate or the position vector, so there's a bit of debate as to what it wants, but I've written that as a coordinate there. 2.5, 1.52. More often than not, it'd be a bit more explicit as to which one it wants, coordinate or position vector. Example here, we've got A, B, C, and D. Point E is the midpoint of BC. Well, there's B and C, the midpoint then. And this is what I was on about, a bit more explicit. It tells me what's a position vector. So I'm going to write OE equals, and just add them together. 5 and 7 make 12, that makes 6. 0 and 8 make 8, so that makes 4 when I half it. 3 minus 3 makes 0. Oh, half it is still 0. Show that ABED is a parallelogram. Well, just imagine this. Just think of it. What you normally do is you take your point and you go round in an anti-clockwise direction. So if that was A, that would be B. That would be E. And that would be D. So it's quite interesting the way you have to go round. Now I've drawn it in an anti-clockwise direction. It wouldn't really matter if you drew it the other way around, because how do you draw a three-dimensional picture anyway? But that implies, if it's a parallelogram, that AB and DE must be the same. So let's find that. AB equals, do you remember what you do? You do B minus A, 5, 3. So I reckon that's 2. 0 minus minus 1, that's 1. 3, 1, that's 2. And do the same thing, DE, that's E minus D, 6, 4. That's, have I done that the right way around? E take away D, yes I have. And that's 2, good, that's a good start, that's the right thing. 4 take away 3 is 1. 0 take away a minus 2 minus 2, yeah. So they are parallel. And now let's do the same thing, we'll do BE. And we'll do AD. So what is BE? There's B. E, and remember you do it the wrong way around, so I'm going to do 6, 5. 6 take away 5 is 1. 4, 0, that's 4. And what have I got? I've got 0, 3, so that's minus 3. And I've suggested AD should be the same as it. So what's AD equal? So that's D take away A. 4 take away 3 is 1. Good, it's agreeing. 3 take away a minus 1 is 4. And I'm going to guess the last one is minus 3. Minus 2 minus that 1, yeah, minus 3. And so I'm going to say therefore ABED is a parallelogram. Let's see if they agree. 6, 4, 0, and obviously this is a proof to show that, so there's very rare the answers for that. So next example, I've got vectors 1, 2, 7 for A, for B, for C. Find the values of P and Q such, oh right, C is parallel to A. Well, I'm just going to do it here. C must equal then K times A. So what's my C? My C is minus 2 P and Q equals K times by A. What's my A? My A is 1, 2, 7. And so you can see if I times the K, or have K to be minus 2, the top line works. You can see that minus 2 times by 1 would give me minus 2. So therefore K equals minus 2. If that's true, this implies that, well, now I know it's minus 2 lots of 1, 2, 7. You can see quite easily that the top line we knew anyway, but it's the P and Q which I didn't know. P is minus 2 times P, 2. So I think P is minus 4. And I think the Q, well, it's minus 2 times 7. Well, it's minus 14. Both negative numbers, but both right. Minus 4 and minus 14. The next thing it says is find the value of the scalar m. Scalar is a posh word for it's a number as opposed to a vector. So it says a plus mb is parallel to this vector. Let's just do a plus mb. What is it? A is 1, 2, 7 plus m, which we don't know what it is, times by b. B is, look at minus 3, 4, 2. And this, it says, is parallel to the vector 0, 10, 23. Again, I can use k. I'm a bit wary about using k because I've already used k. So let's pick a different letter. We'll use lambda. A nice Greek letter for those of you who don't like Greek letters, tough. 0, 10, 23. So we've kind of got two unknowns here, so I think we need two equations. So we just look at the top line initially. I've got 1 minus 3m equals 0. Well, that's quite handy because it tells me straight away that 3m equals 1 and m equals a third. In actual fact, I don't now need to worry about the lambda at all. I could work it out if I carried on. You could see in a different harder question it might ask for both. Both of these things, 2 plus 4m, would equal 10 lambda. But now I know that m is a third, so that's 4 thirds. Plus the 2 is 10 lambda. And what's that? 6. 10 thirds is 10 lambda. I think I've done that right. 4 thirds plus 6 thirds is 10 thirds. So interestingly, this lambda is a third as well. It didn't care about that. We only cared about a third. But there you are. And m is a third is the answer. hidden underneath all that writing. Next question. Find a unit vector in the same direction as A. Well, the same direction is another way of saying parallel, I suppose. But notice it wants a unit vector. So it's a bit more than that. We are being asked to find A hat. So I've already explained in the introduction here that the first thing we do is we find the vector of the magnitude of our vector. So I'm going to do the square root of bit Pythagoras, 2 squared plus another 2 squared plus a 1 squared, ignore the minuses. And if you do that, you get root 9, and root 9 is 3. So I know now its magnitude is 3. So A hat, the unit vector, is simply a third of 2 minus 2 and 1. And of course that was the original vector. And you could actually just put the third in there by multiplication. So it's 2/3, it's minus 2/3, and it's 1/3. And it could be written either of these two ways. Find a vector of magnitude 5 parallel to A. Well, now I know what. See, this has got a magnitude of 1. That's what you're doing. That's why it's called a unit vector. So when I find a unit vector, it's got a magnitude 1 parallel in the same direction as the original A. And now they want me to find a vector of magnitude 5. Well, I simply times what I just found by 5. So I'm going to suggest this would be 2/3 times 5. Well, that's 10/3. Minus 2/3 by 5. Well, that's minus 10/3. And 1/3 times 5, that's 5/3. Again, you could have written it with a number out front as almost like a common factor. But that's how I wrote it there, and that's how I've done it there as well. Example. Point A and B have position vectors A and B. Find in terms of A and B the position vector of P such that M on AB is in the ratio. This looks like a GCSE type question. So if I was to draw a set of axes almost, that's my origin. So imagine I've got a point over here, and I know I don't know anything about it, but I'm just pretending it's over here. And there's my A and my B. And it says, well, obviously a couple of things. First of all, that's A. The vector from 0 to A is A. And the vector from 0 to B is B. Now this is a three-dimensional problem, even though I've only drawn it in two. It kind of follows. And it says, find in terms of A and B the position vector of M. So M is on this line somewhere, such that A to M is 2 to 3. So I reckon it's about there somewhere. That's where my M is. It's not a midpoint, it's just some point. And that is 2 of parts across, and that's 3 parts across. Notice in total these add up to 5. So said a different way, well, bear in mind that AB is, as always, B minus A. Therefore, A to M, because of they add up to 5, and we've got to go 2 parts of that, 2/5 of that, if you like. It's 2/5 of B minus A to go from A to M. And we want the position vector, find in terms of A and B the position vector of M. I want OM. The great thing about OM is you don't have to go directly. You can go from O to A and then add on A to M. And O to A is simply A. That's what we got told at the start. Plus this 2/5 of B minus A for the AM. Now, just multiply out the brackets. Now I'm going to end up with minus 2/5 of A. So I reckon that's 3/5 of A plus 2/5 of B. That's what I think it is anyway. Let's have a look what the answer says. Oh, there's a posh answer. 3/5 of A plus 2/5 of B. Perfect. We like that. And that's it. We're going to have a look at some questions like that in the textbook. So exercise 19E. Thank you very much.